All right, grade 8. Well, today's video is going to be a little bit different just because of the nature of what we're going to do. But the first thing I want to do is talk about different graphs, or officially what we call data displays, of how we show and demonstrate information about data and how we display that. So there's many different types of data displays we're going to talk about. The first one is a pictograph. Now, a pictograph shows data using pictures. For example, this graph here, there we go, looks like a picture of some birds or something uh, based on whatever they're displaying, but they're using pictures. The next one is a bar graph. A bar graph shows data in specific categories where each bar shows how many belong to a certain group. A circle graph shows data as parts of a whole. So if you imagine that the circle represents 100% of the people involved, each color represents something that they selected, what that percentage is, part of the whole group. The next one is line graph, shows how data changes over time. As you can see, we have the line graph going up and down and so forth. You would use a line graph for how you want to show changes. The next one is a histogram. A histogram shows frequencies of data values in intervals of the same size. So there we have our histogram. You notice the bars touching, and it would be like, how many students, were ages 5 through 8, and how many students then were ages 9 through 12. Intervals that are all the same size. Stem and leaf plot orders numerical data and shows how are they distributed. This is by place value. For example, this 3 and that 9 means a 39. A lot of times people use these to show test scores or something like that. We have a box and whisker plot, which shows the variability of a data using quartiles. That kind of has different means and medians, high number, low number, things like that, a box and whisker plot. Then we have a dot plot, shows the number of times each value occurs in a data set. Okay, so if you wanted to know, there's different things you could do. How many times something happened, each dot represents a time something happened. Scatter plot shows the relationship between two data sets by using ordered pairs in a coordinate plane. So a lot of times statisticians will use a dot plot or something like that to show a relationship. As one thing changes, something else is changing. All right, so there's some different things you're going to need to do today. And we'll look at this. Choose an appropriate data display for the situation. So this number A says the number of students in a marching band each year. Okay, well, we're talking about the number of marching students in a marching band every year. So we would want to use a line graph that shows change over time, how the number changes from year to year. A comparison of people's shoe sizes and their heights. Well, a scatter plot would be appropriate because what we're comparing is two things. We are seeing if there's any correlation or relationship between a person's shoe size and their heights. And so we would want to use a dot plot there. So here's a couple of examples. Choose an appropriate display for the situation. Explain your reasoning. The population of the United States divided into age groups. Well, when I look at that for number 1, I think we would want a histogram because we would want one of these histograms here because that shows things in intervals, which means we might have our age group. We might have how many people ages 10 through 19, how many people ages 20 to 29, 30 to 39, and so forth. The number of students in your school who play basketball, football, soccer, or lacrosse. Probably a bar graph to show how many students show each one. I would say probably one of these, a bar graph would be appropriate. I guess you could make an argument for other ones. I wouldn't necessarily choose a circle graph because probably not every student in the school plays one of those sports. And but if it was just a circle graph, you know, based on those who play sports, but there might be more sports than that. The fact that we're focusing just on those sports, I would say um, probably a bar graph would be the best one. All right. So, what we're trying to do here now is we have a situation identifying the appropriate display. Trying to look at a situation and determining what would is a certain data display appropriate. So we look at this scenario. You record the number of hits for your school's new website for 5 months. Tell whether each data display is appropriate for representing how the number of hits changed during the 5 months. Okay, so here we have uh, a bar graph showing how many hits were on the website. Okay, for each month. And we can see on the bar graph that the bar graph clearly tells us how many hits the website got each month. So, like it says here, it would be an appropriate data display. Well, here we have a histogram where it shows the intervals, number of hits between how many months was it between 0 and 399? How many months was it between 407 and 799 and so forth? Well, that would not really be an appropriate display, as it says here, because even though we know, well, there were 2 times that it was between 0 and 400, or up to 400, we don't necessarily know from this data how many were in August, how many were in September, like we do here. So we don't know how many were in each individual month, so we would not want to use a histogram. The final one here would be a line graph, and a line graph would be appropriate because it shows the changes. It shows that the number of website hits kept going up. And based on the dots that are plotted here on my line graph, I can see how many were in each month. So it would be an appropriate data display. All right, the last part that we're going to do is identifying a misleading data display. How do we know if something is misleading? Well, here is 2 graphs that are meant to show the same thing. Box office revenue, whether it was a play or the movies or whatever the case may be. Now, one of these is misleading. The one that would actually be misleading would be this one right here to the left, because this is what we call a broken graph, where it starts at 0 and then it just goes up to 9, 10, 11, and the intervals are not the same. It skips from 0 to 9. Sometimes that's appropriate, depending on the situation, when you want to see high numbers, but it could be misleading because it might give the impression that this is not as high, that it's only part way up. And this one here kind of shows, well, we're way up high on the graph. We get a true number. And it also goes up by 2s, even intervals. So this first one would be misleading because of the broken graph. Well, we have this one here. Which graph is misleading? We have company profits based on billions of dollars and starting year 1 up through year 5. Now, these look like the exact same graph, except when you look at this one closely, you'll see that the bars tend to get wider and wider the farther to the right we go, or the later year it is, which means that would be misleading because the wider graph may lead somebody to believe that that's a larger number or it's portraying something differently. All right, that's a little bit about our data displays today, grade 8. We'll talk to you later. Bye.